My chemistry final project, and if you want to know if it's me or not, well, here's my face. Okay, so let's get on to it. Alright, so the first question is, which compound will produce a carboxylic acid and a ketone when treated with hot, concentrated acidified manganate ions? Alright, so we got A, B, C, and D. Alright, so it's easy for us just to draw it. So I'm going to draw it. This helps me a lot. Alright, let me try. Okay. Alright, so the first step, if you want to know if it can produce, wait, what's the question again? If it can produce carboxylic acid and ketone, well, first of all, we're gonna have to break the double bond. And after the double bond, since the C is alone, we're gonna change it to CO2. We're gonna add a plus. And after we break it, to break the double bond, we're gonna add a OH. Okay, so you can tell if you can look at here, they only have, the C only has two H's left, right? So technically we're gonna have to write it as CH2. So since we can tell now it's CH2OH, right? So we can tell if it is a primer alcohol, and we know that primer alcohols produce aldehyde and carboxylic acid. And in the question, let me check again. The question asks for if the compound can produce carboxylic acid and a ketone. Obviously, since this is CO2 and OHCH2, which is aldehyde carboxylic acid, therefore the answer is wrong. So let's go to B. Alright, let's get B. So we're gonna write B, we're gonna write the right. Alright, look at the question again. Okay, so we're gonna break it again, as usual. Since this is not 1 but 2, we don't write CO2, but we write it as, wait, let me do it. Okay, so we write it like this. We add an OH because here, obviously, we aren't. And once the bond, we break another OH. C. Alright, so look, this is occupied already, and the C here has 2 left, right? 2 H's left, and this also has 2 H's left, which obviously makes it CH2. So we're gonna write here. Same with here. Alright, so this is CH2 and this is CH2. CH2OH is a primer alcohol once again, and primer alcohols produce aldehyde or carboxylic acid. Therefore, if you look on the left side, it's carboxylic acid, and on the right side is carboxylic acid 2, which means there is no ketone. Therefore, B is wrong. So let's go to C. So if we draw C, it's gonna look like this. Alright, so if we look at this, let's draw it. We're gonna have to just split the double bond again. And then we're gonna have to write it like this. C. Remember, after you split the double bond, you always have to add an OH. And over here, we're gonna have to write. Okay, so as you can see, we already broke the double bond, we already added the OH and the OH. Now, if you take a look here, it's already, this C is not like this C. It's already occupied by this C, and the OH. So that, therefore, it's a CH1. This is the same with this thing. Therefore, it's a CH1. And if it's a CH1OH, which is a secondary alcohol, therefore, it produces ketone. But the question asks if the compound can produce carboxylic acid and ketone, but since these two are ketone, therefore this is wrong. Which leads us to the final answer, which is D. And since everything is wrong, there can only be one question right. D is correct. If you want to know how, why? Because look at this. Because C, C, and C. If we write there, then double bond C, 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 and then C. Alright, so look. If we break it, we see this is a C, 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 OH. This is alright. Okay. So if you see this is CH1 obviously, and this is CH2. CH1OH produces ketone, while CH2OH produces aldehyde or carboxylic acid. Therefore, producing ketone and carboxylic acid, thus explaining why D is the correct answer. So that's the answer for number 1, which is D. So let's move on to the next question, which is question number 2. Alright, so for question number 2 is, which reagent may be used to distinguish between propanol and ethanol? Alright, so look, propanol is a ketone and ethanol is an alcohol, right? So if you look at A, which is dinitrophenylhydrazine, which is short for DNH. Alright, so if you look, DNH, let me write DNH. DNH can react with ketone. Don't put a check, so you know it can react. With aldehyde, it can also react. With alcohol, it can't react. Right? So obviously in the question, you want to know how to tell the difference, right? So let me write that. That's right. Alright. So we want to know the difference between let me look at the question again. Propanol and ethanol, which I've said previously that propanol is ketone and ethanol is an alcohol, but aldehyde is also an alcohol. So there is one thing. If you look at C, failing. Look at the question again. Oh, it's failing. Oh yeah, it's failing. Alright. So you look at C, it's failing, right? So it's failing. Alright, failing down. Alright. If you look at failing can react with aldehyde. But can't react with an alcohol. Wait, no, sorry, with a ketone. I'm sorry. Put check here and then here. Alright. So you're gonna be confused. A? Is it A or is it C? Well, I'm gonna say it's C because both of these are alcohols. So I mean, it can be A too, but I'm gonna go mostly with C because aldehyde is an alcohol and ketone is not. So, and in the question 2, you want to know the difference between, you want to tell the difference when it reacts, right? So you can tell by using failing, aldehyde will react, and if it's ketone, it won't react. But if you see at A, with ketone and aldehyde, it will react. But aldehyde is an alcohol, but this alcohol, they can't react. So I'm gonna go with C. Alright, so moving on to question 3. This is the question. You can pause some bits if you missed them. Alright, so on to the solution. I wrote it down to save me some time because I'm already 9 minutes in and the limit's 15, right? So first, what I did here is I wrote the equation on top. So if we're gonna find our P, since you have to find our P, I wrote the equation again, plus HCN. Now what I did is I kind of separated the HCN, so I made it H plus and CN minus, and I also broke the double bond on the O. which gave me CH3, CH, and OH, and CN. Now what I did is I put the H plus onto the O and CN on below of the CH, which gave me P onto Q. So we have to find Q, right? So what I got is CH2, CH, OH plus H2SO4 reflux. So if you're wondering why I took out the CH2, unlike the CH3 where I broke the double bond, I took out the H and I took out a C. You understand, mister? Because I took the H from the CH3, and I'm going to take a C from the CN. So if you see here, what I got is CH2 double bond since I took it out. CH, I put the C double bond in OH. So we're back to Q. Now if we're going to find R, it says that it needs 2 molecules of Q to react. So we're going to take 2. And since this is double bond, I'm going to break it again, and make it a cyclone. Cyclone. So if you can see, it's CH2, CH, C double O, blah, blah, blah. So it's asking for the empirical, right? So let us find the molecule first. So if you can see, let's count the C's first. So 1, 2, 3, 4, 5, 6, C6. And 2, and the H, 2, 4, 6, 8. 8H. And the O, and the oxygen, 1, 2, 3. 1, 2. Oh, I forgot to write it. I'm sorry. I'm really sorry. Alright, so there you go. 1, 2, 3, 4, which is O4. Now, if we're gonna find empirical, we're gonna have to divide it by 2, which is what I did, which is C3H4O2, which gives us the answer. Alright, so let's go to the question 4. Question 4 is similar to question 1, but it's only asking for carboxylic acid. Which compound produces carboxylic acid, not carboxylic acid and ketone? So let's start first. So CH3, CH2, CHO. If you can see here on the right side, CH2, CHO, it tells us that it is a primer alcohol, while in CH3CO, which produces aldehyde and carboxylic acid, right? But on the second one, it's CH3CO, CH3, which is nowhere near primary, so it's a wrong. If you look at CH3, CH2, CH2, OH, it's obvious on the right side that there's CH2 and OH, which means it's a primer alcohol and gives us carboxylic acid. While we look here, there's CH3, CHOH, and CH3. Now, if you look at the middle, it's CH and OH. But CH and OH is a secondary alcohol which does not produce carboxylic acid. That's for making the answer B, because there's only 2, which is CH3, CH2, CHO, and CH3, CH2, CH2, OH. On to the next question. Alright, so on to the last final question. The contact process for the manufacture of sulfuric acid was originally patented in the 19th century and still used today. The key step in the overall process, the reversible conversion of sulfur dioxide to sulfur trioxide in the presence of vanadium oxide catalyst. So we have the equation 2SO2 plus O2, 2SO3, yeah. Alright, so with reference to Le Chatelier's principle and reaction kinetics, state and explain one advantage and one disadvantage of using a higher temperature. Easy. So, if we look at here, I don't know what's this thing called, but it's a minus. It lets go of energy, right? So, if it's a reaction, it will need high temp, because if it's a low temp, it will take a long time to react, which is here, because minus equals low, which is lower in letting go of energy. So what I'm trying to say here is that the advantage of using Le Chatelier's principle is that it will get us SO3 faster. But also the disadvantage is that it has to be done in a very fast time, or else it'll be gone. Just like when we are boiling water, if we don't boil it If you boil it too long, it will be gone. It will evaporate, just like this question. So